Okay, when we last left off, we finished filtration, and that's here again. It seems like we got a long way to go, and we've done nothing but spend two whole lectures basically between this and this. Well, remember, what I really want you to know is that it's a passive process. It only occurs here in the glomerulus and Bowman's capsule together. These things are called the corpuscle. But now we're going to get into these blue and yellow arrows. Okay. And again, you can look down here, you got reabsorption and secretion. And we're not going to talk much about secretion, so don't worry about that. But again, the one thing that I also want you to know is that we haven't talked about these yet either. After this filtrate leaves the corpuscle, it's going to end up in the PCT and then the loop of Henle, number two, and then to the distal convoluted tubule. Okay, so PCT loop and then the collecting ducts at the end. Okay. All right. So that's where we're headed. We're just going to look at reabsorption and secretion for this video. Okay. So you remember, and I hope you do, that we just mentioned it on the last video. Again, I don't know when you watched that video, but filtration is completely passive, no energy required. So I'm setting you up here. Hopefully, if you've read books before, this sounds like foreshadowing almost. So reabsorption is you got to pay for this one, but we'll get to that in a second. All right, so reabsorption, you can see here, begins as soon as it enters the PCT, the proximal convoluted tubule. It's going to bring back ions and water, and it's very, very dependent on hormones, aldosterone, ADH, there's something called ANP, and several other things. Almost all organic nutrients are completely reabsorbed, so that's like glucose and amino acids, although amino acids aren't necessarily organic, but anything with carbon, okay? So sodium is going to come back in, potassium is going to come back in, water is going to come back in, glucose. These are all things that you would have lost if your kidney did not reabsorb it. Reabsorption is a very important process. Again, you would turn into a dry husk in the matter of like 3 to 4 minutes if it wasn't for reabsorption. Okay, right. Well, okay, I said 5 minutes. Never mind. I apologize. 45 minutes. Take about 45 minutes. I think that's overreaching personally, but whatever. There you go. If it would, in less than an hour, you'd be dead. Okay, so there are 3 phases to tubular reabsorption, okay? Filtration was basically you just had it, okay? Filtration's like, all right, we're going to squeeze it out. You had 3 things that kind of governed it. The intrinsic with the stretch, the tubular glomerular, and then or actually let's see, tubular and then sympathetic. Oh, and then I'm sorry, renin-angiotensin. All right, so this one has 3 as well. You have primary active transport, which this should tell you. These 2 words should tell you what else there is. Well, if you got primary active, you're probably going to have a secondary active, and you do. And if you have a active, then you probably have a passive, and you do. So there's 3 processes here. Let's see. So let's just dive into it. So if it's active, that means you've got to pay for it. All right, you got to, it charges you. You need the energy, you need ATP. So what's going to happen here? Just hang in there, right? So I'm not changing. I'm not changing topics here. Sodium, the most abundant ion in your filtrate, is sodium. Okay, and the bulk of the energy, 80% of the energy in this process, is going to be used to bring that back into the blood. This is sodium that was going to be peed out. Your body, but we need to bring it back, not just for the sodium. Okay, you're going to see that in a second. It's not just sodium we need back. We need the things that are going to follow the sodium. And I'll come back to that in a second. Okay. Um, let's see. Do we need anything out of here? No. Okay. No, we don't. Yeah. Okay. So when we bring sodium, okay. So here is your tube. That's okay. That's carrying filtrate. Here's your blood vessels. Okay. You got all the sodium in here, and it's about to be peed out. But what your body's going to do, it's going to take this and bring it back into your blood. And I know you heard sodium was bad for you. Well, too much is, but without sodium, you die. We've been over this 1,000 times. Okay. All right. So this is what's going on. Okay. All this filtrate, sodium got filtered out. But what we're going to do now is in this dark blue, okay, this is the solute. We're going to bring sodium back into the blood. Well, you already know the next step. When you have something over here and water over here, Okay, that's called osmosis. Water is going to go from an area of high to low. It's going to follow the sodium. So sodium's like the leader. Okay, if I want to get somebody, if I want to get you guys doing something, I'm going to convince the leader of the team or the leader of the class, hey, you do what I do, and all the followers are just going to go and follow them and do what they're going to do. So the sodium is the big chief there. Okay, so the main ion that's going to be transported is sodium. 80%, 4 to 5 ATPs is going to be used for that. Okay, now look at this. So we have primary active. Now we got passive. So there are things that are just going to follow sodium because of science. Okay, just it has to. It has no choice. Okay, so there's and this is diffusion. It's facilitated. Blah blah blah. That doesn't mean it requires energy. Just means there's proteins and things that are going to help the stuff move, but it does not require energy. It's an energy-free process. Moves without ATP. Okay, right there, without ATP. The movement of sodium creates two gradients, and you need to know this. Two gradients. An electrical gradient, a gradient is just a hill, okay? Don't get all whoop-de-doo about the word gradient. It just means it's a hill. So remember, things like going downhill. So the movement of sodium creates an electrical gradient. Remember, sodium, as I've drawn it all year long, is positively charged. You know from life in general that negatives are attracted to positives. They opposites attract. So things that are negatively charged are just going to follow sodium back into the blood. Okay? Carbonate. This is carbonate or carbonic. Well, doesn't matter, but it's negatively things that are negatively charged are going to follow the sodium. So we put all this energy into bringing sodium back, and then all the followers are going to go right after it. It also, of course, creates an osmotic gradient. We all know this. You learned this in second grade. Water follows sodium, and this is called obligatory water reabsorption. In other words, water has no choice but to follow the sodium as well. So basically, it's like a 3-for-1 deal. Okay, you go to grocery store and they got a BOGO. Well, this is a buy one get two. I have no acronym for it, but it's a really good deal. We're going to put all this energy into bringing the sodium in, and then we're going to get everything else to follow. We're going to get a whole shopping cart full of stuff that follows it. Now, is there a chance you're going to bring something back that you don't want? Yes, but we'll talk about that in a second. All right, but this is necessary. Okay. Let's see. We don't need to do that. We don't need to do that. Okay. All right. So the first step, primary active. Second step, passive tubular. Last step. See, this was quick. Secondary active. So you get primary and then passive and now the secondary. This is, well, it's what it says. It's the second active. This also requires ATP and energy. Okay. Then this is where you bring stuff in that you just need. Okay. You need glucose, you need amino acids, that's for proteins, lactate, vitamins, of course, and other things like potassium, magnesium, calcium. Those are all cations. Cations, remember, are positively charged particles. Okay. And blah, blah, don't worry about that. Now, there are things that actually, it's like, well, how much glucose does it know to bring in? Well, this is called a transport maximum. I want you to think about almost like a what's that game? Musical chairs. When there's only so many chairs. There's always, if there's 10 kids and there's 9 chairs, only 9 people keep getting to play. If you're at the roller coaster, I think I already did a roller coaster analogy. If you're at a roller coaster and there's 12 cars, 12 seats, and you're the 13th, guess what? You ain't going. You're waiting for the next turn. All right. So there are these proteins in the membrane, and there's whatever 3 glucose and I'm just making these numbers up. Glucose and 5 amino acids, whatever. So they'll fill up all the proteins and anything. So here's glucose coming down, and it's like, nope, can't go there. Nope, can't go there. Nope, can't go there. Well, it's out. It's gone. It missed the chance, and it's going to be peed out. So one of the things that actually governs how much stuff you take back in is just how many transports it has. Okay, but if all the cars are gone, you missed the ride and you're done. So it reflects the number of carriers in the tubules, blah, 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 blah. Basically, it's just open seats. Okay, just think about it like that. Okay, you go to the carpool lane, right? And there's 10 cars and you're the 11th person. Tough. You ain't getting in. It's depressing. Okay. When the carriers are saturated, when they're all full, the excess of the substances are excreted. So that's basically quote unquote how your body knows how to take what to take back in and what to get rid of. It doesn't know. It's just basically a physical presence, essentially. Okay. So again, now we're here. Now we're here talking about reabsorption. We've spent tons of energy bringing back sodium. That water brought water into it, and then other negatively things, and then we went back into this again to bring back other things. So this part, the reabsorption, takes a lot of energy, all these solutes, and water is going to follow that. Follow that. Let's see. Um, okay, so I already mentioned one of the reasons why things don't get absorbed is because the maximum. There's not enough cars to move it across the membrane, which is what I said right there. They lack carriers. They're not lipid soluble. Remember, day one, phospholipid bilayer, phospholipid membrane. If things aren't lipid soluble, dissolvable, then they can't get through that membrane and they're not going to be able to transport through. And and what if it's just too stinking big? Things like urea, creatinine, uric acid. Okay, these are all things left over from your body working, right? You don't want these. Some of these things, almost all of these things actually get excreted through your sweat as well. But you don't want these things. These are leftovers and waste. Your body can't really do much with these anyway. So they're too big and they're going to be excreted and peed out as well. You don't want them to be reabsorbed. Okay. Actually, yeah, this yellow here, and again, you don't have to know that, but if you have a lot of creatine or pardon me, not creatine, creatinine in your urine, well, it could be that you're, supplementing, and I no comment. But it could mean that you're breaking muscle down. Um, that you, um, again, it could just be that you've gotten to a big regimen, or it could mean that something that your muscle tissue is breaking down when it shouldn't be. So high levels of creatinine, higher levels of creatinine, is a good measure for your rate and all that stuff to make sure that your kidneys are. It's only it's not supposed to be reabsorbed at all. So if that number is a little bit high, then something, and you it's just a good tell. Again, could be that you're supplementing. Again, most of you know that if you do take creatinine, creatine, pardon me, creatine, which is creatinine's the product left over, you're supposed to drink up your water intake tremendously because it is so hard for your kidneys to flush it out. Okay, still on the absorption. Um, let's see. So this is going. This is so we're okay. Let me back up. You've got filtration, reabsorption, secretion. Filtration's only at the corpuscle. Okay, that's easy. That little first part. Well, the rest of these things kind of happen throughout. Nothing's really isolated or specialized. They can all kind of do it. So what this slide's about, well, out of the PCT, the DCT, and the loop, how do they do this, or how much do they do? Well, as you would expect, the first tube that the stuff comes to is the PCT. So you would imagine that they're going to be the most active in reabsorbing. Why? Well, because there's more stuff to reabsorb. So let's see, maybe I can back up to the slide. Yeah, let's back up to the slide. So right here, here's the PCT. So all this filtrate comes in here. Well, doesn't it just make sense that this tube right here is going to be the most active in reabsorbing? Of course it is. You got more filtrate in there than you do down here. By the time it gets down here, there's hardly anything left. So that's going to be more active there. Okay. Um, bulk is the electrolytes. That's sodium, potassium, and calcium, and magnesium, and all those things. Chloride. And then you can see here. This is it. This is a. You don't have to understand these numbers, but look at it. 125 mils per minute enter the PCT. 40 mils per minute enters the loop. Okay. So from the time it begins to the time it stops, about 80 mils per minute. Okay. That's again, I'm not going to do percentages for you because I don't have my calculator. I can't do math in my head, but that's a lot. Let's see. Well, it's obviously what is it, a third is left over? Yeah, about a third is left over, less. That's how active the PCT is. Okay. So what is reabsorbed? Glucose, lactate, amino acids. And then you've got these percentages. Don't get hung up in the percentages. Just look. You got sodium and water, bicarbonate, that's like a baking soda, chloride, potassium. Again, don't get hung up on the percentages. That's not that important. And then a bunch of electrolytes. Calcium phosphate, that's for your bones. Okay, and magnesium. This actually goes back to the skeletal system. And these are all going to be controlled by your hormones. Okay. All right. So tons of stuff, all the good stuff, glucose and amino acids, sodium, water, bicarbonate, all these things for digestion, for nervous system, for muscles, for bones, for everything. Everything we talked about all year. Okay. Now, what's interesting is that uric acid that we don't really want actually gets reabsorbed. But check this out. It's going to be put back in later. So that seems a little bit silly, but whatever. I'm not in charge. The second tube that stuff comes through is called the loop of Henle. It's different. Okay, duh. This is the one with the really long loop that we talked about a long time ago. The cortical and the juxtamedullary loops. Okay, nephrons. Water can leave the descending part, but not the ascending. Just don't get hung up on that. And again, we talked about this a couple lectures ago, that because it either has a short loop or long loop, it can either form really dilute or really concentrated urine. But it also absorbs water, sodium, chloride, potassium, and you can see here that sometimes, like, what did it say up here? Water can leave the descending, calcium's absorbed in the ascending. All right, so there's differences. Don't get hung up on that. That's too specific. But again, most of the same things, just in a lot less percentages, 10, 20, 35, 30%, not nearly as much as the PCT. And then the last two, the DCT and the collecting ducts, by the time it gets here through the rest of the tubes, by the time it gets to the PCT, the loop of Henle, only 10% of the originally filtered stuff is there, NaCl and water. So very little is left over at this point. The flow is about 25. It started at 100. Now, started at 125. It's down to 25 mils per minute. So what goes on here? Nearly all of the water and sodium reaching these can be reclaimed. It doesn't have to be. Depends on if you need it. If you're hydrated enough, you're not going to reclaim that. If you got enough salt in your body, sodium in your body, you don't need it, but it can be reclaimed. It can be. And then in the absence of hormones that change things, actually these ducts are relatively impermeable to water, so they really aren't planning on taking that water back. But you would have to put in different hormones like ADH and all that stuff to actually get it to take the water back up. All right, so what did we just do? Okay, so after this, filtrate. This is where most of it happens, 125 mils per minute. By the time it gets to the loop, okay, it's down to about 40 mils per minute. And then you can see here, water is going to be reabsorbed here, and then solutes here. Okay, remember, there's some specifics here, but I said remember. You don't have to remember that. Just whatever, okay? And then here is the DCT. By the time it gets here, only 10% left. And then you can see actually, and there's some secretion here, but you still got some changes. You can see this kind of dashed line here, this here. That means it's variable, changes, depends on what you need. See, it's all dashed, these are dashed lines here. Just depends. And then eventually anything that's left over, right there, urine. Okay? It just depends on you. Maybe it's a real hot, sweaty day and your body's going to do whatever it can to retain as much salt and water as possible. Or maybe you had the opposite. Maybe you were sitting at home doing nothing but eating potato chips and water. Okay? And it's like, well, that's too much. We're going to try to get rid of a lot of that stuff. Okay. So if you watched the second lecture, which I hope you did, I don't know why you'd skip that one to go to this one, but you're teenagers, you do weird things. All right. Most reabsorption depends on hormones. So these hormones are things that we talked about on the last lecture. One of them is called aldosterone. You might remember this is all about blood pressure. Okay. This is going to trigger the absorption of sodium. And like we just said a few minutes ago, when sodium gets taken back up, well, look, water follows it. And you bring water back into the blood, you're going to increase your blood pressure. Okay. Again, this is all about regulating blood pressure. It's important again, which that water is for everything, for blood and blood pressure, for your brain, cerebrospinal fluid, for your plasma, for your lymph, for these, again, whatever percent of your body, 60, 80% of your body's water. So many parts of your body rely on it. If you don't have aldosterone, sodium is not reabsorbed, and you're going to dump a ton of sodium and water. Okay, which don't stress about that. I'm sure you're fine. Here's one we didn't talk about yet. So we talked about aldosterone in the last lecture. Aldosterone was one of the things that came out as a result of the renin-angiotensin pathway. Here's another one. It's called ANP, atrial natriuretic peptide. Okay, this is interesting. This is a hormone. It's actually secreted by, look here, the atrial cardiac cells. The heart, amongst many other jobs, actually acts like a gland. It releases hormones. Okay, when the blood volume or blood pressure is too elevated, basically the heart, when it feels like it's working too hard, is going to secrete this hormone, and it's going to make sure that sodium doesn't get reabsorbed, that it stays in the tubes. Well, if sodium stays in the tubes, water is going to follow it out. You're going to pee that out. Well, you get rid of all that water and your blood pressure drops. Okay. So if your heart's working too hard, it's too much volume or too much blood pressure. Well, one way to get rid of that extra pressure is to get rid of the blood volume. One way to get rid of the blood volume is to get rid of the water. One way to get rid of the water is to get rid of the sodium. So it actually makes you release sodium. So if you're trying to keep track of this, this works in contrast to aldosterone. Aldosterone sucks the sodium back up. ANP makes you release it. Okay, so it reduces the water reabsorption and the blood volume, which I already stated. Okay, and well, right. Well, I already talked about aldosterone. We'll talk about ADH in just a second. Although we did talk about that in the last slide, the last lecture. Okay, so aldosterone increased deep blood pressure by sodium and water. ANP, the opposite. Okay. All right. So we'll do secretion and then we'll pause for another video, probably, I think. Haven't decided yet. Okay, so secretion. So we've mentioned this a couple times. Actually, let me back up. So what have we done? We did filtration. We spent literally 2 lectures on filtration. And then we just spent the last whatever minutes talking about the reabsorption, all these blue arrows here. Okay, things coming back into the blood. Well, what if we took stuff back that we don't really want? Well, we have another chance to kind of dump it back in. And this is called secretion. And this is, you can see where this happens. It happens at the tubules, mainly. Not here, but mainly at the PCT and the DCT and the collecting duct. So reabsorption in reverse. Okay, so reabsorb, we took stuff in that we needed. This is just putting stuff back out that we don't need. So it's the main, once again, also the main site is the PCT. Again, that just makes sense. It's the first tube that stuff comes to. And things that we're going to secrete, hydrogen and potassium ions. Hydrogen actually plays with your pH level in your body. So you got to regulate that. You don't want, it's again, a nice balance. But by getting rid of that or keeping that, keeps your pH in order. Potassium ions, creatinine, again, that's muscle breakdown. Ammonium ions, that's from your muscle, your body working. You don't really need that. And some, whatever, okay? So eventually, you have in your urine things that are filtered and secreted. But why is it important? Why are we, we filtered, got it out of the blood, we absorbed it, put it back in the blood, and now we're literally putting it back in the blood again, back in the tube again? Perhaps. Okay. So, things that we don't really want there anyway. So any kind of drug, penicillin, of course, antibiotic, phenobarbital is a depressant. Um, People who convulse sometimes are given phenobarb. Anyway, so it gets rid of things that aren't already in the filtrate. So this was too big to filter out. Okay, in the original filtration, too big. But now your body's actually going to pay some money to get it out of your body. You've all heard that some medicines and drugs are processed by your kidneys or your liver. Okay, this one's processed, stuff like this. Some are processed by your kidney. Again, whenever you take certain things, they always talk about drinking plenty of water and all that stuff because you got to help your kidneys get rid of that stuff. It also gets rid of things that were reabsorbed. So accidentally you reabsorb some stuff, not accidentally, but you reabsorb things that you shouldn't have. And so this is a chance for your body's like, never mind, I don't really want that. Okay. But you go to the grocery store, it's like, I don't want this. You put it back on the shelf. Okay, get rid of it. So it eliminates undesirable substances, things that were reabsorbed passively, things that just followed sodium. It's like the guy that comes along on a date when he wasn't invited. I can get rid of that guy. Gets rid of excess potassium. Too much potassium can actually kill you. So again, I don't know how much potassium is too much. Me and my banana a day thing, but um, too much can literally screw around with your heart. You may remember the EKG, and one of the signs of certain part of the EKG was too much potassium. Controls your body pH, which I talked about a minute ago with the hydrogen protons. And right, yeah, right here, the hydrogen ions. Again, you don't have to know all that. That gets pretty complicated here with the hydrogen ions. But basically, your pH is controlled by taking in or by getting rid of certain things. Okay. Again, you don't have to know all that. And there's a cute, not my child, but somebody's child that they posted. Strange. Okay. All right. So once again, to recap, you got the filtration, which we talked about last time, and then the reabsorption, and then here's the secretion. You can see secretions taking place everywhere. Well, the PCT and the selecting duct, not here. The loop is all about reabsorption. Okay. Um, let's see. So just to kind of tie up here, and then we'll probably pause, put one or two more slides, then we'll pause. We'll go to the next, probably the last slide, last video. So there's this term called a diuretic. You may have heard of that. People that basically want to lose weight, one of the simplest ways to do it is by taking diuretics, things that actually make you lose water, pee more. So it's any chemical that enhances urinary output. Okay, that, and anything can act as that. Um, for example, many of you know that one of the signs of diabetes that's undiagnosed, maybe somebody gets it later on in life, adult onset type 2. One of the things that happens later on is they become very, very thirsty and they start peeing a whole lot more. Well, what happens is this glucose, okay, this glucose that we all eat and drink and all that stuff, okay, it wants to get into your cell. It's supposed to say cell, okay. Well, for some reason that glucose can't get in. With diabetes, can't get in. Insulin's supposed to help that, but for whatever reason, not enough insulin, or it's not working anymore. The cell's not listening to insulin. So this glucose that should be absorbed just stays out in the blood. Well, when that glucose gets filtered out in the kidneys, okay, well, doesn't just follow salt. Water follows anything if it's high and low. So water's going to follow the glucose out to pee more. And so one of the signs of diabetes that's not being diagnosed is they typically have to go to the bathroom a whole lot more than they were before, and they're awful, awful thirsty as well because they're losing all this water. Okay, but there are other examples of diuretics. Alcohol, of course, inhibits the release of ADH. Okay, ADH, which we didn't talk about again this time, but that's anti-diuretic hormone. This hormone makes you keep water. So this alcohol inhibits the thing that makes you keep water, which means it makes you lose water. Okay. So again, um, personal things aside, if you have some sort of alcohol or you've seen somebody do it, chances are you've seen them have to use the bathroom a lot because it actually makes you release more water, alcohol. Caffeine and things like that, and tea and coffee and all that stuff, they also are going to make you pee more essentially, but they do it differently. They inhibit sodium reabsorption. So it kind of works like up here that water is going to fall. So instead of sodium being taken back up into your blood, what's that? That's supposed to be sodium taken back into your blood. Sodium stays in your tubes, and again, water follows it out. So again, if you drink a glass of tea, it's like, man, I really got to pee, or a cup of coffee. It's like, man, why did I got to pee so bad? Well, the caffeine is actually making you lose more water because it's making you lose more sodium. Okay. So again, everything in moderation doesn't mean you should stop drinking tea or coffee, but just moderation. Let's see. Stand by. I'm just checking something. Okay. This will be the last slide for this. A little math problem because I know everybody likes math. So almost all of you, I would imagine, unless you just haven't, have been to a doctor before and they've made you pee in a cup and something like that. Okay. So what in the world are they doing that for? All right. This is the general thing. There's 1,000 things they could look for, but it is actually quite useful and it is non-invasive. It's a little bit weird and embarrassing, but it's non-invasive and that's good. So it's called renal clearance, the volume of plasma that's cleared of a particular substance in a given time. So that's what they're doing. They've got all these tests, all these different things they can look for in values, and it should be within a range. And when it's out of this range, then it's usually it's usually worth a phone call. Okay, so that's what renal clearance is. Determines the filtration rate, which provides make sure that they know that your kidneys are functioning properly, and it can also be used to detect damage. So there's a formula, there's some math, and I'll tell you right now, on your test, you're gonna have to do some math. It's very simple though. Okay, so here it is. Your renal clearance is equal to U times V divided by P. It's funny, they made it P. Okay. The U is the concentration of the substance in urine. The V is the flow rate of the urine formation. And P is the concentration of the same substance in plasma. So U and V are actually, pardon me, U and P are actually related. The concentration of the substance in the urine, the concentration of the substance in plasma. Okay. And then it in the numerator side, on the top part of the fraction, you're going to multiply that by that. Okay. And there's different things. Again, creatinine, ammonia, urea, uric acid, glucose, whatever it is, they have values for these things. Okay. They have standards, or they just, well, the concentration of substance in urine. You go pee in a cup, they do a blood test, and then they just kind of use standards, and they can determine what your renal clearance is, and there's numbers and things, and that's that's why they do it. This whole slide talks about something that you don't need to know about at all, so don't worry about it. Okay, so I'll leave you with this slide. If you've ever seen the movie Dodgeball, that'll make you laugh, or maybe not. Okay, so I'm going to end up here, and then when we come back, the next lecture will be, in my opinion, the simplest part. We'll talk about what basically urine's supposed to look like, and then the other parts of the urinary system, because believe it or not, all we've talked about up till now is the kidney. Well, believe it, obviously, because we haven't talked about it, but the rest of it's fairly simple, okay? All right, well, that's it, and I'll see you guys next time.